Hi everyone, and welcome to this particular video on the capital asset pricing model. And in particular, in this video, we're gonna focus on the security market line and sort of problems relating to the securities market line. So suppose that we're gonna deal with two problems mainly. So let's start with the first problem. Suppose that the rate of return on a T-bill, we know that the T-bill is risk-free. So this 5% rate here is our risk-free rate. So suppose the market rate, the rate of return on the treasury bill is 5%, and the expected rate of return required by the market for a portfolio with beta of 1 is 12%. Now, according to the CAPM, okay, we're asked the following questions. The first one being, okay, what is the expected rate of return on the market portfolio? Okay, so notice what we have here is since the beta is equal to 1, that's like a perfect scale constant, okay, then by construction, okay, its expected rate of return is also 12%. Right? That's just it being 1. Of course, if we have a different beta, it would be a different sort of solution. Okay, next, so the first two questions are more like conceptual. Next, what would be the expected return on a stock if, for example, the beta is going to be equal to 0? Well, beta equals 0 implies that there is no systematic risk in the economy. Therefore, the stocks expected rate of return in the market equilibrium, is 5%. Okay, so that's going to be equal to 5%. Okay, so just sort of like a concept check, how do we get the expected rate of return? Well, it's just this formula ER equal to the risk-free rate plus the beta times the market rate of return, say RM, that's this one, so RM minus the risk-free rate. So in the case of A, since this is perfectly equal to 1, right? RF is going to be 5%. This one is going to be 12%. And this is going to be 5%. So the difference between this one, okay, will be 5% plus 7%. And that's going to be 12%, right? So that's how we got this one. And for this one, you have that ER is equal to RF, which is 5%, right? Plus beta times RM minus RF. But this beta here is going to be 0. So this entire thing cancels out. That's why you're left with 5%. Okay, so just if that wasn't that clear, that's how you sort of compute for it. Now, suppose that you consider buying a share of the stock at a price of 40 bucks. The stock is expected to pay $3 in dividends for the next year, and you expect to sell it for 41. Okay, and the stock risk has been evaluated at some beta equal to negative 0.5. And we're asked the question, well, is this stock overvalued or overpriced or underpriced? Okay, so how do we do that one? Well, first, okay, what is the expected return? The expected return, well, we can just use the SML, okay? The security market line equation, that's ER, that's this formula that we have here, equal to RF plus beta times RM minus RF. This is equal to 5% plus, okay, you have negative 0.5 times 12% minus 5%, right? And if you calculate this, you get a rate of return of 1.5%. Okay, so what we have here, so that's the expected return, but okay, the actual the actually expected rate of return using the data we have in the problem, using the data is just ER equal to, okay, so you can sell it for 41 bucks, 41, and you expect dividends of 3 bucks, so that's plus $3, divided by the initial price of 40 bucks minus 1 to find the return, and that's equal to 0.10 or 10%. Right? So in this case, because the actual expected return exceeds the fair return, the one we compute from the formula of the SML, fair return, the stock is underpriced. Okay, so that's pretty straightforward. Okay, so that stock in particular is going to be underpriced. Okay, so that's that there. Okay, so what do we go from now? We're gonna go to the next problem. The next problem being, suppose we have the following table below. In this particular table, we have two states of the world, right? So you have a market return state of 5%, and you have a market return state of 25%. We are given with two stocks, right? Two stocks, an aggressive stock and a defensive stock. So the aggressive stock at the 5% market return has a return of negative 2%. The defensive stock is 6%. Meanwhile, at the market return of 25%, the aggressive stock return will be 38%, and the defensive stock will be 12%. So the first thing we are asked, okay, is we calculate the beta, okay, the beta for each of these two stocks. So let A be equal to the aggressive stock, and then D be the defensive. Okay, so if you recall, beta is the sensitivity of the stock's return to the market return. That's how sensitive a particular stock I's return is to the overall market return, which means that it corresponds to the change in the stock's return per unit change in the market return. So how those two co-move together. So how can we compute the stock's beta? Well, it's just the difference in the return across the two scenarios divided by the difference in the market return. So how does that go? So for example, for the aggressive stock, well, in the first state of the world, which is 5% market return, okay, so that's 0.05 or the 5% market return. The return is 2% or minus 0.02, right? And in the second state of the world, that's at 25%, so that's 0.25, 0. So we have a return of 38% or 0.38. And computing this, we get 2.00. So that's beta A. Then therefore, beta B, okay, beta D rather, would be equal to something similar. So we again have the same denominator, and then the only thing that will change is the rate of return. So at the 5% state, it's going to be 6%, and then at the 25% market return, it's going to be 12%, right? And we have 0.30. So those are the betas of those two stocks. Okay, so now that we've computed for the betas, we're asked what is the expected rate of return on each stock if the two scenarios for the market return are equally likely. Well, this is sort of a simple question. We're just going to weigh it by 1/2 because it's going to be a perfect average. So the expected rate of return on the aggressive stock is just going to be 1/2. That's because two scenarios that are equally likely times, well, you can get a negative 2% return or a 38% return. 0.38 is equal to 0.18 or 18%. So that's the expected rate of return on the aggressive stock. Meanwhile, the expected rate of return on the defensive stock is computed similarly, except we use the rate of return on the defensive stock, which is 6% and 12%, right? So we're going to have here 0.09 or 9%. right? So that's the rate of return on the defensive stock. So not too much complications. Again, we're able to do this because the scenarios are equally likely. Okay, next, now comes the fun bit. We get to draw. Okay, so if the T-bill rate is 6%, so this is your RF, right? Your risk-free rate, and the market return is equally likely to be 5% or 25%, draw the SML for this economy. Well, recall the SML or the security market line is determined, okay, determined by the market expected return. Okay. Return. And what's the market expected return? Well, if the two things are equally likely, that's gonna be 1/2 times the first state of the world is a 25% market return. The second one is a 5%. So you have 0.05 plus 0.25. Okay. Which means you have here a 15% expected return of the market. Okay. You have a beta of the market equal to 1, right? So the beta of the market is going to be equal to 1, right? Well, how do we find this one? Well, it's simply because if you look at the formula, it's going to be 0.05 minus 0.25, and then this is 0.05 minus 0.25. Similar how we computed letter A, that's going to be equal to 1. And we're given a risk-free rate equal to 6%, right? So therefore, what we have here is we can draw the line. So the equation that we're going to start with, it's going to be equation for the SML. For SML is equal to expected R of the market equal to the risk-free rate plus beta times, okay, the market return, the expected market return, in this case, it's 15% minus the risk-free rate, knowing that the risk-free rate is 6%, right? And that the beta is going to be 1. So we have 6% plus beta times 0.15 minus 0.06, or let's just put this in 0.06, right? So in decimal form. So meaning if the y-axis is expected return, we're going to start at the intercept of the risk-free rate, which is 6, so it's roughly here, and is going to be sloping upward at this particular slope because that's going to be a positive number. So say it goes up something like this. Okay, something like that. And that corresponds to our SML. Okay, why is it positive? Because 0.15 minus 0.06 is a positive line. Okay, so that's it for letter C. Okay, letter D, we're asked to plot the two securities on the SML graph. So we're going to use the same graph and plot the things. But first, we need to compute for the alphas of each of the securities. So how do you do that? Well, okay, based on its risk, the aggressive stock has a required return, expected return of, okay, expected by RA is equal to, okay, RF, right, RF, okay, plus the beta that we computed for, okay, plus beta times the rate of return of the market, RM, which we computed for before, minus RF. For that particular security, the risk-free rate is 6%. So that's 0.06, like the last question. The beta is going to be 2. It's this beta here, because that's the aggressive stock. So plus 2 times 0.15, which is what we computed for as the expected rate of return on the market, minus 0.06, right? And what we get here is 0.24 or 24%, right? So the analysts forecast for the expected return is only okay, 18%, right? So if you recall from our problem, okay, that will, we have here at letter B, at the equally likely scenario, the expected rate of return on each stock, if the two things were equally likely, is 18%. So we can compute for the stocks alpha. So the stocks alpha is alpha A, which is the actual expected return. Oops. Expected return minus the required return given the risk, okay? So that's going to be 18%, right? That's the actual expected rate of return minus the required return, which is what we computed for, 24%. So that's going to be equal to minus 6%, okay? So similarly, for the defensive stock, okay? So we use the same formula, expected value RD is equal to RF plus beta times RM minus RF. But recall our beta now is going to be 0.3. That's what we computed for here of 0.3, right? Our risk-free rate is still 0.066% times a 15% return on the market minus the risk-free rate of 0.06, right? So what we have here is going to be 8.7%, okay? Now, the forecasted return or the actual return is 9%, okay, based on our forecast in B. So the alpha would be, alpha D is equal to, okay, what you found, which is the 0.9, okay, 0.09 minus this 8.7%, 0.087, which means that we have a plus 0.003 or a 0.3% expected alpha, okay? And what we can do is now, having done this, well, we can calculate, having calculated the alphas, we can now graph the securities in the SML. So this is quite simple. Notice that the beta of the aggressive security, so let's do that in pink, that's going to be equal to 2. So it's going to be somewhere here, right? That's going to be the beta of the aggressive security. Well, the aggressive security has a beta of 2 and an expected return equal to 18%. So that's going to be somewhere here. Okay. So that's going to be here. So let's call this A, the aggressive security. Meanwhile, we have the defensive security in blue, whose expected rate of return is, whose beta is 0.3. So somewhere here, somewhere along here. And the expected rate is 9%. So somewhere along here, maybe. Okay. So we have 9%. Whoops, not 9%. We have here D. Okay, and we have the market. The market has a beta of 1, right? The market, that's in red. The market, okay, has a beta of 1, and it has an expected return of 15%. So the market is somewhere along here. This is the market. Okay, and okay, what's gonna happen is, notice the expected return of A, for example, let's plot one of the alphas. In this case, let's plot A, the alpha A, okay? That expected return is somewhere around here, which is 18%, okay, if I'm not mistaken. That's going to be 18%, right? But what we found when we used the formula, okay, this SML formula is, we found a return of 24%. So a 24% return was what we actually predicted was. So this is the 24%. So meaning this distance here corresponds to alpha A, right? So that's alpha A. This distance of 6%, that's alpha A. So that's it for our particular video on the security market line and the capital asset pricing model. Thank you for your attention, and I'll see you in the next video. Thank you very much.